Hello friends, welcome to our YouTube channel. I am Aman and I am going to teach you science. Okay. Before starting this lecture, let's go to the previous lecture. What we have discussed in the previous lecture? We have discussed about charges, unit of charges, okay, quantization of charges. Then we studied about electric current. Then after electric potential. Then potential difference and the difference table between voltmeter and ammeter. These were the topics that were covered in the last lecture. So if you have not studied it yet, then go to the playlist and please watch that video. Now in this lecture we will study about Ohm's law, which is very important. It is very important for this chapter because this chapter is all about this Ohm's law. The concept of this chapter is near about related to Ohm's law, so it is very important to understand. What is Ohm's law? It gives a relationship between potential difference and electric current. What does it give? It gives a relation between potential difference and electric current. Just see here, this is Ohm's law. What does it state? It states that at constant temperature, the electric current flowing through the circuit at constant temperature, mark this word, at constant temperature, okay, the electric current flowing through the circuit is directly proportional to the potential difference. The electric current is directly proportional to potential difference across the ends of the conductor. This is also important, across the ends of the conductor. Why it is needed to write here across the ends of the conductor? We have already studied about potential difference. Potential difference is the difference of electric potential between 2 points. We have already studied that. Let's see here. If this is point A and this is point B, the difference between the electric potential of A minus VB, that will give us VAB. I have explained you in last lecture, so please visit that. So this is the difference between the electric potential of these 2 points, which is called as potential difference. So if we are taking potential difference, it means it must be between any 2 points, of a conductor. So that 2 point is ends of the conductor. Okay. So this is also important to mention here, ends of the conductor. So what is Ohm's law? At constant temperature, very important. I will explain you why it is important, why we need to write at constant temperature. When I will explain you more about the resistance, details about the resistance, then you will come to know why it is important to write here at constant temperature. The electric current flowing through the current is directly proportional to the potential difference across the ends of the conductor. If we see this statement mathematically, we will find V is directly proportional to I. What is V? V is potential difference, PD. PD means potential difference across the ends of the conductor. I is electric current. So V is directly proportional to I. So V is equal to R into I. If we remove this proportionality sign, we place a constant. Which constant? That is called as proportionality constant. So here this R is the constant. Which constant? Proportionality constant. So V is equal to, as we replace this directly proportional sign with equal sign, a constant comes between that, and that constant is resistance R, which is called as resistance. So V is equal to R into I. We can arrange it, V is equal to IR, because this is very famous, V is equal to IR. So I arrange that V is equal to R into I into V is equal to IR. These two are the other forms of this formula. If we need to find potential difference, what is the formula for potential difference? Electric current into resistance. Electric current into resistance. If we find electric current, what will happen? If we find electric current, what we need to do? We will transfer this resistance from RHS to LHS. What will happen? I is equal to V by R. So I is equal to V by R. This is the another form of same formula. The next one, if we need to find resistance and potential difference and current are given, then we can use this formula R is equal to V by I. See here, from here R is equal to V divided by I. We can get resistance. Okay. So these are the different forms of this formula. Very, very important concept is this. Ohm's law. At constant temperature, what is that? At constant temperature, the potential difference across the ends of the conductor is directly proportional to the electric current flowing through the circuit. Okay. You can copy it or take a screenshot. Now, a new term is introduced in Ohm's law. We have already known about electric current and potential difference in last lecture, but a new term is introduced, that is resistance. What? Then a question arises in your mind, sir, what is this resistance? What are the factors on which this quantity depends? Okay. So let's see what is resistance and on what factors this resistance depends. So our next topic is resistance. Okay. So we will see resistance. Resistance means to resist, to resist or to suppose objection, to object anyone. Okay, this is resistance. Suppose current is moving in a conductor. So what is the work of resistance? It will not allow the current to flow through the conductor. It will resist the flow of current. So resistance is nothing. It is a property of a material which resists the flow of current or which objects the flow of current. Okay. What is resistance? It is the property of a material. We can write it as it is the property of a material to resist the flow of current. In a conductor, or we can say in a circuit. So it is the property of a material to resist the flow of current in a conductor or in anything. In a conductor also, if we say resistance of an inductor, that will be very high. That's why the current is not allowed to flow through an inductor. If we take conductor, the resistance is less. That's why the conductor allows the current to flow through it. Therefore, the resistance of the conductor is less. If we discuss about semiconductors means it allows partial current to flow through it. It means the resistance range of semiconductor is between conductor and insulator. The resistance is very, very high in insulator. That's why current is not allowed to flow through the insulators. In conductors, the value of resistance is less. That's why the current is allowed to flow through it. And the third one is semiconductors. It allows partial current to flow through it. That it means the value of resistance is between the conductor and the insulators. Okay. So it is the property of a material to resist the flow of current. We can write up to here also. Then it is also correct. In any material, we can call it as inductor, conductor, or semiconductors. No need to mention conductor, or if you write in a conductor, it is also correct. Not an issue. Okay. So resistance is nothing, a property of a material. If we talk about this material, this is inductor. Means the property of this material is to resist the flow of current. It is 100% true. Okay. Every material resists the flow of current. So this also resists the flow of current, but the resistance, the value of resistance in this material is more. That's why no current will flow through it. It is an inductor. When we talk about a copper, so copper allows the current to flow through it, but there is also a resistance. Copper allows current to flow through it because it is a conductor, but there is also a resistance. Some of the current is not allowed to flow through it. Means there is something which resists the flow of current, which does not allow the current to flow, but the power of current or that resistance value is too less, that's why the current allows to flow. That's why in a conductor current flows easily, because the value of resistance is less. So on what factor this resistance depends? On what factors resistance depends? Okay, someone asked you this question, on what factor this resistance depends? Is it variable or is it constant? Will it change or not change? If we change the condition, will the value of resistance will change or not change? So on what factors resistance depends? First thing is temperature. Temperature. The resistance depends upon temperature. If we change the temperature, the value of resistance will change for the same material. If copper is placed in 20 degrees centigrade, then the value of resistance we will calculate, and if the copper is placed in 60 degrees centigrade, then the value of resistance we will calculate. We will observe that the value of both the condition, in both the conditions the value of resistance is different. It means the value of resistance depends upon temperature. Increasing, if we increase the temperature, resistance will increase in a conductor. So we can say resistance is directly proportional to temperature. If we increase the temperature, resistance will increase. If we decrease the temperature, resistance will decrease. Second one is, okay, nature of material. Nature of material. Resistance depends upon nature of material. Means what type of material we are giving. Suppose we are taking iron, then the resistance value will be less. If we are taking plastic, the resistance value will be more. So it depends upon the nature of material. Okay, that's why all the substances, all the material is categorized into three categories: conductor, semiconductor and insulators. Okay, so it also depends upon nature of material. Third one is length of the conductor. Length of the conductor. R is directly proportional to L. Suppose if we have to move 1 kilometer, next day you have to move 2 kilometer, in both the condition, in which condition you will feel more resistance? If suppose you have to supply current from here to here, or in next case from this place to this place, so length of this conductor is more, so resistance will also be more. As the length increases, the resistance offered by the conductor also increases, because if the length of the journey will increase, the resistance will also increase. Okay, so length of the conductor is directly proportional to resistance. The resistance value depends upon length of the conductor. If the length of the conductor is small, resistance will be small. If the length of the conductor is more, the resistance will be more. Last case, fourth one is area of cross section. Area of cross section. Resistance is inversely proportional to area of cross section. More the area of cross section, less will be resistance. Less the area of cross section, more will be the resistance. Now, for example, suppose there is a 6 meter road. Okay, width of the road is 6 meter, and there is another road whose width is 3 meter, and on both road we are giving 100, we are allowing 100 people to move together. So in which road movement will be easy? Having width 6 meter or having width 3 meter? Obviously having width 6 meter, the movement will be easy. It means resistance is less. If the movement is easy, it means resistance is less. So more the area of cross section, less will be resistance. More the area of cross section, less will be the resistance. That's why if the wire is of this size, the resistance will be less. If the wire is of this size, resistance will be more. Okay, because area of cross section is less as compared to this one. So area of cross section will be more, resistance will be less. Area of cross section will be less, resistance will be more. It is just inversely proportional. Okay, write it down or just take a screenshot. Now we will use these two equations. Make it as equation 1, equation 2. So see here, from equation 1 and 2, from equation 1 and 2, what will we get? R is directly proportional to L and inversely proportional to A. R is directly proportional to L and inversely proportional to A. As we remove this proportionality sign, we get a constant that is called as rho L upon A. And what is this rho? Where rho is equal to resistivity. Resistivity. Where rho is equal to resistivity. Now what is this resistivity? Sir, आप तो आज एकदम न्यू टर्म्स एक्सप्लेन कर रहे हो. रेसिस्टेंस. नाउ दिस again new term came, resistivity, and we know there is another name is specific resistance. This is also known as a specific resistance. Now what is resistivity? We have seen, okay, it is a constant. It is proportionality constant, because as we remove this proportional sign, it came in consideration, rho, resistivity. Now we will learn what is this resistivity. Let us define this resistivity. See, let from here, see here, let area of cross section be 1 meter square. I have supposed the area of cross section of the wire is 1 meter square and length of the wire is 1 meter. What I have considered? I have considered the area of cross section of a wire is 1 meter square and the length of that wire is 1 meter. So we will put it here. What will happen? R is equal to rho 1 upon 1. That means R is equal to rho. It means resistivity is nothing. It is just a resistance, but in a special condition. That's why we call it a specific resistance or resistivity. What is that special condition? This is the special condition. When length of the conductor is unit and the area of conductor is also unity, then the resistance offered by the conductor is nothing, a specific resistance or resistivity. Okay, let us make it clear. Once again I am explaining this. Sorry friends, camera में फिर से problem आ गया. Okay, no issue. So what we are discussing? Okay, we are discussing about resistivity. Resistivity is a special resistance when the conductor is of 1 meter length या unit length and its area of cross section is unity. Okay, so resistivity is nothing a special resistance. That's why its another name is a specific resistance. So what will be its definition? See its definition. Sorry. Resistivity or a specific resistance. See, the resistance offered by a conductor when its length is unit. Okay, when its length is unit and its cross sectional area area is also unity. Okay, the resistance offered by a conductor when its length is unit and cross sectional area is also unity, called as resistivity. Okay, this unit and unity means 1. If we take it here, A is equal to suppose 1 मीटर को निकाल के हम लोग क्या लगा दे सेंटीमीटर स्क्वायर एंड इन सी हियर सेंटीमीटर, देन द रेजिस्टेंस इज आल्सो इक्वल टू रेसिस्टिविटी. सो व्हाट वी हैव टू टेक यूनिट. यूनिट मींस 1. इट इज फ्री फ्रॉम units. Units means this. If we are taking in centimeter, if we are taking in meter, if we are taking in decimeter, if we are taking in kilometer, nothing changes. Just the unit of these two will be same and its magnitude should be 1 unit. In magnitude should be 1 unit. Unit means 1. So its length is unit and its area of cross sectional is also unity. Then the resistance offered by that conductor is called its resistivity or a specific resistance. Now think, if someone asks you, then on what factors this specific resistance depends or this resistivity depends? On what factors? See, resistance depends upon 4 factors: nature of material, temperature, length of the conductor, area of cross section. But in a specific resistance or resistivity, see here, area of cross section is fixed. Area of cross section is fixed. Length of the conductor is fixed. So what is variable? Nature of material and temperature. So resistivity depends upon nature of material and temperature. Only these 2 factors, not all 4. ऐसा नहीं कि if someone asks you on what factor resistivity depends, you write all that 4 factors. No, you have to write only 2 factors. Resistivity depends upon only 2 factors, that is nature of material and temperature. So factors on which it depends, factors on which it depends. What are that factors? First, nature of material. And second one is temperature. Okay, these 2 only. On what factors resistivity depends? Nature of material and temperature. What is resistivity? It is a special resistance offered by a conductor when the length of the conductor is 1 or unit and its cross sectional area is unity. Okay, and on what factors resistivity depends? Resistivity depends upon nature of material and it also depends upon temperature. And on what factors resistance depends? Then we will write nature of material, temperature, length of the conductor and area of cross section. We have to write all 4. Okay, so I guess your concept is clear about Ohm's law, resistance and resistivity. Confirm? If you have any doubt, please comment on this video. Now we have done with Ohm's law, resistance and resistivity. Clear hai? So next one is the graphical plotting the potential difference and current on a graph. Okay, we have studied V is directly proportional to I from Ohm's law. Okay, so when we will plot a graph, VI graph, see here, if you are plotting a VI graph, V, potential difference on Y axis, I, current on X axis. Okay, potential difference on Y axis, current on X axis. This will be its volt. SI unit of potential difference is volt. SI unit of current is ampere. Okay, so what will we see? We will see a straight line. This is a straight line. Plotting vi means if it is 0, if we mark it a 1, this will be 1. 2, then 2. 3, then 3. If it is 4, then it is 4. Means the ratio should be same. Now just see here, slope. You know slope. What is slope? Slope is equal to y by x. Slope of a graph is nothing, it is y by x. Y value divided by x value at any point on the graph. Suppose on this point we are going to find slope at this point. We are going to find slope at this point and this point. Suppose this is R1, this is R2, this is R3 and this is R4. Okay, these are the points. R1, R2, R3, R4 are the points, and we are going to find slope at these points. So what will happen if V is directly proportional to I? It means the slope at any point on this graph should be same. Mark my words. If two quantities are directly proportional to each other and if we are plotting a graph between them, then the slope of that graph at any point should be equal. So the slope at this point R1, R2, R3 and R4 should be equal. And how do we calculate slope? Slope is nothing, y by x. So see here, slope will be y. What is y? In y axis what is that? V, potential difference. In x axis I. And now from Ohm's law we know V by I is nothing, resistance. I have explained you. See, what does Ohm's law say? V is equal to IR. Therefore R is equal to V by I. So see here, slope V by I. It means V by I is equal to slope, and from here V by I is equal to R. Comparing these two equations, it means slope is nothing, resistance. It means slope is nothing because resistance is also equal to V by I. Slope is also equal to V by I. It means resistance and slope are equal to each other. Therefore, we can write here slope is nothing, R is equal to slope. R is equal to slope from equation 1 and from equation 2. It means if we find the slope of this graph, we will get resistance. If we find the slope of the graph, we will get resistance. In some questions, this graph will be given and you need to find the resistance. So what will you do? You will find the slope of this graph, you will get the value of resistance. How will you find the slope? Slope is nothing, y by x. So at point R1, see here, at R1, the value of resistance will be V. V is 1 and I is also 1. So 1. Okay. Now next, 1 ohm. At R2, see, R is equal to V, y axis 2, x axis 2, 2 divided by 2 is 1 ohm. R is again 1 ohm. At similarly at R3, 3 by 3, 1. At R4, 4 by 4, 1. So resistance, the value of resistance will be constant. You will get the constant value of resistance. This is the representation of potential difference and electric current by Ohm's law, according to Ohm's law, because they are directly proportional to each other. Okay, note it down. In some cases they may ask to draw this graph. So what will you do? You will take the different values of V, potential difference, and at that potential difference you will calculate the value of current and you will plot this graph. So graph should be like this. Okay, if they have already given this graph, they will ask the value of resistance. So you can find from any one case, any one, R1, R2, R3, R4, at any one point you will find the value of resistance. That value of resistance will be valid throughout this graph. Okay, note it down or take a screenshot. Now one more important thing, that is unit. What is the unit of resistance and resistivity? So SI unit of resistance and resistivity. We know resistance R is equal to V by I. What is the unit of V? Already explained you, volt. What is the unit of I? Ampere. That's resistance. The unit of resistance is volt per ampere, and we know 1 volt per ampere is equal to 1 ohm. So this is the SI unit. This is the SI unit of resistance. What is the SI unit of resistance? The SI unit of resistance is this sign. See, this is called as ohm. Because resistance is found out from which law? Ohm's law. That's why he put the unit of SI unit of resistance as ohm and denoted by this sign. You have to make like this. This is ohm. Okay? Ohm. So what is the SI unit of resistance? That is ohm. And 1 ohm is equal to what? 1 volt per ampere. So if someone asks you, define 1 ohm resistance. Define 1 ohm resistance. I am writing here question. Define 1 ohm resistance. So what will be the answer? 1 ohm resistance means if the potential difference across the ends of the conductor is of 1 volt and the current flowing through that conductor is 1 ampere, then the resistance offered by that conductor is of 1 ohm. When 1 ohm resistance will offer? When V is 1, A is 1. If both is 1, then resistance will be of 1 ohm. Means when 1 ampere of current is flowing through a conductor having potential difference of 1 volt, then the resistance offered by that conductor is of 1 ampere. Write down this question and you have to write this answer in your own words. Okay? Now next, resistivity. Okay? Next one is resistivity. What will be the unit of resistivity? See, R is equal to rho L upon A. We have already R is directly proportional to L, R is inversely proportional to A, and when we remove proportional sign we will get this rho. So rho is equal to RA upon L. So take R. What is the SI unit of resistance? Ohm. Into what is the SI unit of area? Meter square. What is the SI unit of length? Meter. So what? Ohm meter. So what is the SI unit of resistivity or a specific resistance? That is ohm meter. Okay? This is ohm meter. What is the unit of resistivity? Ohm meter. Or we can call it as also a specific resistance. Okay? So, okay, done. So what we have studied today, we have studied Ohm's law, then resistance, factors on which resistance depends, then resistivity, factors on which resistivity depends, and the SI unit of resistance and resistivity. Okay, what are the formulas we have studied today? These are the formulas. V is equal to IR, I is equal to V by R is equal to V by I, and R is equal to rho L upon A, and rho is equal to RA upon L. These are the formula. Other forms, actually we have studied all of these formulas. Formula number 1, formula number 2. But these are the different forms of the same formula. So there are some numericals based on this formula also. So I will take that numericals in next lecture. I will make a separate lecture for that numerical. That is probably next lecture. In next lecture I will cover these all numericals, and then after that we will start combination of resistances. Next topic of this chapter is combination of resistances. But before starting that combination of resistances, we will complete numericals. We will do 3-4 numericals on these formulas so that you can understand the concept, the basic concept, the theory. That is very important. In this lecture, I have explained you the theory, what is resistance, what is resistivity, Ohm's law, graphical representation, how to find the resistance from graph, or how to plot that graph, finding the value of current at different potential differences. Okay, so done for today. Please like, subscribe our channel. If you like our lectures, please subscribe it. Okay, thank you.